Okay guys, in this video we're going to apply some of the theorems that we talked about with chords and segments and circles in the last video. And so in our first picture here we have a circle E centered at E. And we see that BEA and CED, those angles are both 70. So those are central angles. And I want to know what, let's see, I'm given AB. So AB is 7. I want to know what CD is. So we know that these two are congruent. And if these two central angles are congruent, that means that these arcs are congruent. And if the arcs, the intercepted arcs are congruent, that means that these chords are also congruent. So if these chords are congruent, then x equals 7. Okay. Moving here, we have, let's see, we have 3 chords here. 1, 2, 3 chords. And we have, let's see, these 2 chords are congruent. Okay, these 2 chords are congruent. And we have lines, the distance from them is 3x minus 5 and x plus 2. Okay, so 3x minus 5 and x plus 2. Now we know that since we have a from the center, okay, the distance from the center is perpendicular, and these are congruent chords, then we know that that distance must be the same. So we know that 3x minus 5, let's see here, 3x minus 5 equals x plus 2. Okay, so if that's true, then 2x equals 7, so x equals 3.5, or 7 over 2. All right. We also need to find y here. Well, y, we know that this is, we know that these two are congruent. Okay, so if these are congruent coming from the center, and if we know, I think we need to know that this is 90 degrees. Okay, if that's 90 degrees there, then, so that has to be given to us. Then we know that these two are also going to be congruent. So y is going to equal 7. Okay. Coming up here, we have an angle here. Okay, so this is a central angle again, and it's 70 degrees. And we notice that arc AB is congruent to this arc. So if these 2 arcs are congruent, that means, well, if we find the measure of this arc, well, what's the measure of this arc? The measure of, we'll call this CD. Okay, so the measure of CD is equal to 70 degrees. So if these 2 are congruent by given, then the measure of arc AB also equals 70 degrees. Okay. Finally, over here, we have a circle, 2 chords that are congruent, so they're both 5. We want to know the measure of this arc. Okay. So let me just draw in some angles and letters here, A, B, C, and D. Okay. So we've got that. We know that ABD, even though it doesn't look like it, is 210 degrees. So the measure of angle ABD equals the measure of arc, and I need to put another letter in here since it's a major arc, AED, which equals 210 degrees. Okay, so if that equals 210, then we know that these two, well, we know that the rest of this area, the rest of this arc measure must be 360 minus 210. So 360 minus 210 is 150. So this must equal 150 degrees, all of this. Now, since we know that these chords are the same, okay, since these chords are the same, that means that these arcs are the same. And if the arcs are the same, that means we can just divide this by 2. So 150 divided by 2 equals 75 degrees. And that's going to be what x equals. Okay. Hopefully this helped you guys get a little better understanding of how segments and chords play a role in circles. Sometimes these things seem obvious. Other times in math, as we'll see next, some things aren't so obvious. But now you should know, even though it looks obvious, that sometimes you have to understand why that is. And so we've proven that, and then I actually worked through some problems here. So thanks for watching, and hope to see you again.